So in the last class, we discussed the last thing is that when a chemical reaction occurs, the bonds are broken down initially of the reactant particles. And when these bonds are broken down, the energy is absorbed, right? And when after that, what will happen? The bonds will form to form products, and as those bonds are formed, the energy is released. So if the amount of energy released is greater than the amount of energy which is absorbed, the reaction becomes exothermic. Or if it's opposite to it, then reaction becomes endothermic, right? Okay. So here you can write these statements. The examiner asks you to explain bond break reaction being exothermic or endothermic in terms of bond breaking and bond making, then you will do this. And endothermic reactions more energy is taken in during bond breaking then the amount of energy given out when bonds are formed. Is this understandable to all of you?
Yes,
Yes,
sir. Yes, sir.
Okay, then in exothermic reaction, more energy is given out or released during bond forming, then the energy absorbed or taken in during bond breaking. So are these two reasons are clear to all of you?
yes, sir.
Yes, sir.
Okay. Now, so if the examiner sometimes asks this reason that, and it's, I think you guys have did in your O levels as well, that to explain the reaction being exothermic or endothermic in terms of bond breaking and bond making, right? Now, the next thing that we have is bond energy. So basically, it is the amount of energy that is needed to break the bond. So, but you have to define it very concisely. So you will write it is the amount of energy needed to break one mole of a specific covalent bond in a gaseous state. So that is important, being gaseous state, because before, if it's not gaseous, if molecule doesn't become gaseous, then the energy is basically used up to convert the state. So a molecule must be gaseous, the bond must be covalent, then the energy that we provide, and as a result of absorbing that energy, if 1 mole of a covalent bonds are broken down, then that is considered as bond energy. Is this clear to everyone? If any one of you have any confusion, you guys can ask, please.
Sir, this talks about this breaking of covalent bonds. So what about ionic?
Because in ionic there is no one bond, right? Ionic bond always results in, lattice, giant lattice. So there are multiple bonds.
Yeah, so there won't be any bond energy?
No, there is no bond energy. The bond energy is only for covalent bonds, where basically if you recall, all the ionic substances are solid at room temperature, right?
Yes.
So there is going to be their energy needed to melt them or then vaporize them. That's it.
Oh, okay, sir.
Okay. So is this definition is clear? Hamza, Ashal,
Yes, sir.
Kubra?
Yes, sir.
Okay. So its unit. We know that usually we use the unit for energy is kilojoule, but as we restrict it to 1 mole, so it is going to be kilojoule per mole. And the other thing, it is the amount of energy needed to break the bond. So it means it is always endothermic, right? And now, why we are studying this and why we are discussing this? Because if we have to calculate the enthalpy change of a reaction, so that enthalpy change of a reaction can be calculated by bond energy values. If we know the bond energy values, we can calculate the enthalpy change of a reaction. And how can we do it? We use this expression that if you have to calculate the enthalpy change of a reaction and you are given with the bond energy, so you have to do the sum of bond energy for those bonds which are breaking down during the reaction, and then minus sum of bond energy for those bonds which are found during the reaction. So that is the expression which we are going to use to calculate the enthalpy change of a reaction if we know the bond energy. Yes. Is this understandable?
Yes, sir.
Yes, sir.
Okay. Yes, Kubra and Amna.
Yes, sir.
So see, these values usually are provided to you in the paper. So see, here you have a, if you can see, the bond energy values are given like these. Okay. Now we are going to look at the question. How to attempt the question from these bond energy values, okay? So okay. Now, is this question is readable? Yes?
Yes, sir.
Yes, sir.
Okay. Now, you have to understand. First, see what they are asking. Ethanol reacts with hydrogen cyanide in the presence of a small amount of NaCN. So, it means NaCN is basically a catalyst, and that's why they didn't show you in the equation. Now, what they are asking, use bond energies to calculate the enthalpy change for this reaction, include a sign with your answer. Okay. So, the most appropriate way of doing or calculating the enthalpy change of a reaction with the help of bond energies is this, that in the first step, make their structures with the bonds, so you will easily identify which bonds are actually broken down and which bonds are being formed. So we know it's CH3, which clearly indicates me that there is a carbon which is bonded to 3 hydrogens like this, right? So there is a carbon which is bonded to 3 hydrogens, then this carbon is bonded to a carbon, then CHO. So remember, whenever there is a CHO written, it means that carbon is forming a double bond with the oxygen, and that same carbon is forming a bond with hydrogen. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, Amna and Kubra?
Yes, sir.
Okay, now after this we have HCN. So H always form a single bond. So H, there is a single bond between hydrogen and carbon. How many number of bonds a carbon atom can make?
4.
4. So there is going to be a triple bond between carbon and nitrogen. One bond of carbon is made with the hydrogen and the remaining 3 forms with nitrogen. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now if you look at the product, in product we have a C H3, which means a carbon is bonded to 3 hydrogens, and then a carbon with a H. Let me write the H. OH, which means there is a O and that O is bonded to a hydrogen, and CN, so it means C triple bond N. Now have a look at this. Now you are observing all the bonds which are in the reactants and in the product, right? So if you make this structure, then you are easily able to identify which bonds are broken and which bonds are formed. So how you will identify the bonds which are broken? Hamza, can you identify which bonds are broken?
Sir, why is there no double bond with C and O in the result?
Because it's C, there is a OH over here, isn't it?
Yes, sir.
So it means there is a O bonded to an H.
Okay.
Now, Hamza, can you identify which bonds are broken? Yes, Hamza.
Sirs,
Yes. Who can tell me which bonds are broken? Ashal? Okay. Now, listen carefully. The easiest way to identify which bonds are broken, the bonds which you are not seeing in the product, but in the reactants are the bonds which are broken. The bonds which are not present in the product, but are present in the reactant are the bonds which are broken. Is this clear?
Yes, sir. So the
Yes.
oxygen double bond will be broken?
Yeah, it means oxygen carbon double bond will be broken. Because see, it's not there in the product, right? Yes, Ashal and Hamza, did you understand?
yes, sir.
Yes, sir.
Yes, Kubra.
Yes, sir.
Now, can you identify which other bond is broken?
HCN.
HCN is the molecule. Which bond is broken?
H and C.
H and C in HCN. Good, Ashal, because you see that C triple bond, the carbon which is bonded to nitrogen is also bonded to hydrogen in the reactant, but when in the product, that carbon is bonded to another carbon, but not with the hydrogen. So it means this bond is broken. So I have highlighted the bonds which are broken. Is this clear?
Yes, sir.
Yes, sir.
Yes, Kubra and Amna?
Yes, sir.
Yes, sir.
Okay. Now which other bond is broken? Miss, can you find any other bond which is on the reactant side and not on the product side?
Sir, on the product side, there is OH bonded with
Yeah,
carbon.
no, I'm
along-
right now asking the bonds which are on the reactant side but not on the product side. First, figure out any bond which is on the reactant side and not on the product side. Yes, is there any other bond?
No, sir.
No, sir.
No, there are no
No,
other bonds. So it means we have identified the bonds which are broken. Yes, Amna, what you were telling, can you repeat what you were saying?
That there is OH bonded to carbon on the product side, but there is no OH bonded to carbon. So the OH is formed, right?
Yeah. So how you identify, very good, Amna, how you identify which bonds are formed are the ones which are on the product but not on the reactant. So O is bonded to hydrogen, that is on the product, but that this bond is not present in the reactant. So it means this bond is formed, right? Right. Is this clear or not?
yes, sir.
Sir.
Okay. Now, if you see in the product, a carbon is bonded to oxygen with a single bond, right? Right.
Yes.
Yes.
Yes, sir.
And in the reactant, the carbon is oxygen bonded to oxygen with a double bond, which we have highlighted that it's broken. So it means this bond is also formed.
Yes.
Okay. Now, if you see the carbon which is forming a triple bond with the nitrogen is bonded to a hydrogen when it's reactant. Now in product, it's bonded to another carbon. So this bond is also formed. And if
Yes,
you
sir.
see the rest of the bonds are the ones which are present on the reactants, and these similar bonds are present in the product as well. So these bonds are, we consider them that they are neither broken nor formed, right?
Yes, sir.
Yes, sir.
Yes, Hamza? Yes, Kubra, is this clear to you?
Yes, sir.
Yes, Amna?
Yes, sir.
Yes,
Okay.
sir. Okay.
Yes, Hamza, is this clear to you as well?
Yes, sir.
Okay, Ashal, did you understand?
Yes, sir.
Okay, now if I see the bonds which are broken, BB is a carbon oxygen double bond and hydrogen carbon single bond, right?
Yes.
And the bonds which are formed are oxygen hydrogen single bond, carbon oxygen single bond, and carbon carbon single bond, right?
Yes, sir.
Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, now we will take the help from the data booklet
Sir,
to find
but
their values.
carbon single bond is not being formed, it's just broken into double bond.
Can you repeat again?
So carbon oxygen single bond in the product side is not formed, it's just broken from the reactant side.
Yeah, you can think like that. There is a carbon oxygen double bond is there, right?
Yes, sir.
So, which is not in the product, right?
Yes,
So it means it's broken, right?
sir, but it's not formed also. It's just broken.
1 minute. First, tell me what I am asking.
It's broken.
Okay. In the product, you are observing a carbon oxygen single bond, right?
Yes.
Do you find a carbon oxygen single bond in the reactant?
No, sir, it is double bond.
It's the double bond. So it means we consider it as this is the bond which is formed.
Okay.
Okay. So keep this in mind. If there is a bond which is in the product, which is present in the product, but that bond is not present in the reactant, then it means this bond is broken. Oh, this bond is formed. If there is a bond which is present in the reactant, but not present in the product, that means that bond is broken. And if the bond is present in the product, but not in reactant, it means this bond is formed. So carbon oxygen bond is not present in the reactant, right? carbon
Yes,
oxygen
sir.
single bond, but present in the product. So it means it is formed. Is this clear now?
Yes, it's clear.
Okay, now have a look. If you see over here, there is a C double bond O and there is a C double bond O in CO2. So here this C double bond O is not in CO2, right? So I am going to take this value, which is 740. Then the other bond is carbon hydrogen bond, which is over here. Its value is 410. Then OH bond, CO bond, and CC. Okay, there is a CO single bond over here. Its bond energy is 360. So I'm going to put 360 over here. Then carbon carbon single bond. It is over here 350. So I'm going to put 350 over here. Then I have a OH bond. This here we have OH bond. Its bond energy is 460, right? So
Yes, sir.
I'm going to take 460 over here. So what was the formula of enthalpy change? Is equals to bond breaking minus bond forming, right? So
Yes, sir.
enthalpy
Yes, sir.
change is equals to add them, then add them as well. So 0, 5, 11, 15. 0, 17, 11, 70. So if you subtract it, you are going to get minus 20. So minus 20 kilojoules per mole energy is released. Is this clear?
Yes, sir.
Yes, sir.
So if you do it in this way, then it will be very easy for you. So first we have to make the molecules, their structures, in which each bond is shown, so you can easily identify which bonds are broken and which bonds are formed. Then put the broken bonds on one side, their bond energy, the bonds which are formed, their bond energy on the other side, take the sum, then subtract it, you will get the enthalpy change. Yes, if any one of you have any question, please ask. Yes, is this clear to all of you?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay. Now here you go. Now can you guys do this question? Okay, so in the first we have to do the same thing that we did over here. Make the structures with all bonds shown. Do it quickly.
Done, sir.
Done. Okay. Hamza and Ashel, send me after showing all the after drawing all the structures. Do it quickly. Okay, if you are done, can you have a data bond energy values? Yes.
Yes, sir. I have the data booklet. Maybe just.
Okay. So if you have a data booklet, then try to solve it and send me the solution. Kubra, if you are done as well, do it. Ashal and
Okay, sir.
Hamza, send me the structures first. And if you both can also send me the structure so I can check whether you did correct or not. Okay, I have received from Kubra. Let me check. Okay. Very good, Kubra. Yes, Ashal and Hamza, I'm waiting for you guys.
Sir, I'm doing it.
Amna, you can also share the structures with me.
Yes, sir. Okay.
No, Ashal. How many bonds a hydrogen atom can form, Ashal?
Sir, one.
One. So see, you show one hydrogen forming 4 bonds, isn't it?
Yes, yes.
How? Okay, I've received Amna's. Very good. Hamza, waiting for you. Okay, received yours. You don't know what is ammonia, Hamza? No, Amna, that is wrong. Okay, so as I was expecting, there are some confusions. So first have a look over here. Hamza, what is the formula of ammonia?
NH3.
NH3. So if you see, you make N2H4, H3, isn't it?
Yes, sir.
So see, nitrogen, between nitrogen atoms in nitrogen molecule, there is a triple bond.
Okay.
Then we have 3 moles of hydrogen, and then here we have 2 moles of ammonia. So this is one ammonia molecule and this is another ammonia molecule, right?
Okay.
Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay,
Yes,
now
sir.
have a look. Let me ask you a question. Ashal,
Yes, sir.
uh, Can you tell me which bonds are broken?
Sir, nitrogen triple bond.
Very good. And
Hydrogen.
there are three bonds, 3 moles of hydrogen bonds, and we are not observing any hydrogen bond in the product. So it means hydrogen bonds are broken, but there are 3 moles. So I have to multiply its bond energy times with 3. Is this clear?
Yes, sir.
Yes, Hamza?
Yes, sir, it's clear.
Yes, Amna and Kubra?
Yes, sir.
Yes, sir.
Okay. Kubra, can you tell me which bond is formed?
NH form.
Okay. Good. But how many NH bonds are formed? Amna, can you tell me this?
Sir, 6.
6 NH bonds are formed, so I have to multiply the bond energy of NH with 6, right? Is this clear now?
Yes, sir.
Okay. Yes, Hamza and Ashal, is this clear?
Yes,
Yes.
sir.
So here we have a nitrogen triple bond. Its bond energy is 944, right? So I am going to put 944. If you will find hydrogen bond, its bond energy is 436. So I'm going to put 3 times 436. So if you do it 3 times 436, then what it will be?
1312.
Sorry. Can you repeat?
So 1312, I guess. Let me confirm.
1312. Is this
Sir,
what?
1308.
1308. Okay. Now add these two.
Sir, 1472.
1472.
72. Yes, sir.
Okay. So
सर मेरे पास 2252 आ रही है.
Yes, sir, it's 2252.
yeah,
Yes.
yes, because 1308, and if you added 944, it is 2252. Amna, can you check again? Hydrogen single bond.
Oh, yes, sir. Sorry.
Okay, good. Hydrogen single bond, its bond energy is 390. So 6 times 390. Can anyone tell me the value?
2340.
2340. So the energy for bond breaking is 2252 and the energy for bond forming is 2340. So you have to subtract these. Can anyone tell me the answer, please?
Minus 88.
Minus 88. Is this clear?
Yes, sir.
Okay. Yes, Ashal and Ahmed, is this clear?
Yes, sir.
Okay. If you guys have any confusion, please ask. Okay then. Hamza, how many bonds a carbon atom can make?
So 4.
4. How many bonds chlorine can make? Ashal, can you tell me?
Sir, one bond?
1 bond. Good. Okay. Now, keep this in mind. Carbon makes 4 bond, hydrogen make 1 bond, chlorine make 1 bond. Draw this structure. Everyone, and then calculate the enthalpy change as well. Okay.
Okay, sir.
Sir, can you check the structure, please?
Okay, very good. Now find the enthalpy change. Okay, very good. Kubra have done with the solution as well. No, Amna. Amna, check your working or show me the structure and the working you did, so I will tell. Ashal and Hamza, I'm waiting. Hamza, your answer is not correct. Yes, very good, Ashal. Your working is fine. Now solve it and tell me the answer. Amna, if you see, it's C2H5Cl, right?
Yes, sir.
So where is that carbon chlorine bond in the product? You missed that.
Oh, okay, sir.
Yes, look for the do the correction, Hamza. Check where you did the mistake, and Ashal,
Okay,
as you
sir.
finish the solution, share the answer. So it is going to be like this, right? So if you see, the bond broken is one carbon hydrogen bond and one chlorine chlorine bond, right?
Yes, sir.
And the bond which is formed are one carbon chlorine bond and one hydrogen chlorine bond, right?
Yes, sir.
The bond energy of carbon hydrogen bond is 410 and carbon chlorine bond is, yes, now your answer is correct, Amna, 340.
Sir, I checked it from Google, sir. That's why my answer is wrong. Carbon hydrogen
Sorry?
bond is showing 413.
410 and 340. Okay. So it is going to be 750 minus carbon. No, sorry, it's chlorine chlorine bond.
Sir, chlorine is 242.
Yeah, 242, sorry. It's 242. Carbon chlorine is 340. Yeah, it's 340. And hydrogen chlorine is it's 431. So here 652 and here 771, right? So if we subtract it, we will get minus 119. Is this clear?
Yes, sir.
Yes, sir.
Yes, if still any one of you have any confusion, do ask. Okay, now the next subtopic that we have to start or that we will be doing, we will do this one in our next class is calculating enthalpy change using experimental results. Previously, we have calculated the enthalpy change by the help of the bond energy values. Now, instead that if you have the experimental results and from those experimental results, how can we calculate the enthalpy change. That is what we are going to do in our next class. Okay. Okay, till here is this clear to all of you?
Okay.
Yes, sir.
Okay, so we will be starting this in our next class on our next class will be on Wednesday, right?
Yes, sir.
Okay, then take care, everyone.
Allah.
Allah
Allah Hafiz,
Hafiz.
sir.
Allah Hafiz.